Hello everyone, welcome again in Eng-Man YouTube channel. So we will continue our learning on PVTP software and still about the compositional oil modeling. Now we will start the regression process. In previous videos, we have completed the checking for CCE, differential liberation, and separator train. So I'm going to close this. Okay, we will start the regression. We will have primary regression and second regression. All right. And for now, we are in the primary regression. We will now perform the initial regression on the liquid density, saturation pressure, and separator density and GOR, which act as anchor point. And we will do the regression using critical temperature, critical pressure, binary interaction coefficient, right? And volume shift of the pseudo components. Those are the things that give us degrees of freedom to achieve the matching. Okay, so we need to highlight this first, PVT fluid, and then we can double click on add regression in this characterization wizard. Okay, and yeah, sorry, let me do that again, double click. Okay, again, ensure that the PVT sample here is highlighted in this select characterization path, this navigation tree, before doing everything. All right, so we are inside the regression. Okay, and let's check the block that we have. You see here. So by double clicking on this regression, you will add a new block, which is called regression after PVT fluid, and the output after regression is currently called PVT fluid 1. We can edit label, right click, and you can call it fluid reg 1 for regression 1. Okay. Very good. And you can see we are in this regression input. You can also go to lab data weighting. This is the first thing that we do. And lab data weighting, the PVT sample will be based on the PVT sample here. And we have 4 experiments: saturation pressure, constant composition expansion, separator train, and differential liberation. Okay, the first step is the lab data weighting tab. This is where any data points that we do not want to be included in the regression can be excluded, and other data points can be set with specific weightings. The idea being that selecting fewer data points to match to will give the regression algorithm flexibility and additional degrees of freedom to achieve a good match. As the experimental data has already been added to the PVT sample object, all of the data is automatically populated into this regression data object. Okay, so that's the first thing. Now let's start with the saturation pressure. Okay, so we will in turn checking the saturation pressure, CCE, separator, and differential liberation. This video will be only for saturation pressure. Okay, so saturation pressure, we have the temperature, 185, saturation pressure itself, 2076, and density at saturation, 641. As the saturation pressure is definitely something that we will want to match to, this data will be left included. Okay, so everything here will be included. If you don't want to include, let's say, density at saturation, you can highlight this and then press on exclude, something like this. But if not, you can press it again, include, and everything will be included. Okay, it should be noted that obtaining accurate measurement at the bubble point, especially for near critical fluid, will be difficult, as the liquid and vapor phase become hard to differentiate. To avoid these uncertainties, we may wish to instead regress on fluid density near rather than at the saturation pressure itself. Okay, and again, saturation pressure is very important. That's why for the weighting, we maintain this 10 grading, which means it's of high importance. Okay, so yeah, now we are in this high grading, the 10 high weighting. Okay, so I think that's all. Again, we will not be rushed. We will do one step at a time for this PVTP because it's a learning process and fluid modeling is very, very, very important in reservoir simulation and reservoir engineering analysis. So let's do this one step at a time. Okay, in the next video, we will do most of the thing here, but for the but for the constant composition expansion experiment. Okay, until then, see you and thank you.